With this video, I want to introduce you to humoral immunity. So we talked previously about this branch of the adaptive immune system and the fact that it is working against pathogens in the body that are floating around in body fluids, or what used to be known as body humors. So this is antigens that are in the blood or in the lymph. B cells, or B lymphocytes, are the major cell type that's involved in the humoral immune response. And the encounter between these B lymphocytes, or B cells, and an antigen usually occurs in the spleen or very often in the lymph nodes. What we've got in this diagram over here is a representation of what happens when a B cell that's immunocompetent encounters its one specific antigen. So I kind of want to walk you through this particular diagram here and get you familiar with the response of the humoral immune system. If you look at this picture up here, we've got 3 lymphocytes. The artist is trying to represent them as having different receptors simply by differentiating the colors of the receptors. So this one here, this first one, has these receptors that are kind of green. They're of a different shape out here at their tips. This one has receptors that are blue, and these receptors are going to be immunocompetent for something different than the receptor on this cell, which is also going to be different from what this cell over here is immunocompetent for. So the body gets introduced to some antigen that's represented by these little red circles that you can see in here. We'll say it's varicella virus. So varicella virus, which is the virus that causes chickenpox, has been introduced into your body. And what I want you to notice is that only one of these 3 cells, of these lymphocytes, B cells, is actually binding to the varicella. It's the one that's immunocompetent for varicella virus. This one here and this one here and all of the other hundreds of thousands of different types of B cells that are located throughout your body are not going to respond to this invasion of varicella because they are immunocompetent for something else. So basically, they just ignore this. Now, one of the things that you should know that's not shown on this diagram is once this B cell has bound to the antigen that it's immunocompetent for, it's going to take that varicella virus and it's going to show it to a helper T cell. The helper T cell is then going to activate the B cell so that it can respond to the varicella. And once that B cell becomes activated, it's going to proliferate to start to form clones of itself. So remember, if we've got one virus particle that has been introduced into the body, it's likely that there are thousands, tens of thousands more that are out there, and we're going to need more than one cell kind of mounting an immune response against this virus. So our cell that was immunocompetent for the varicella virus is going to start to produce clones of itself. And so in this diagram here, we've got really kind of a simplified representation. We're seeing just a couple of clones being produced. The reality is there's going to be thousands of these clones produced to help to fight against this varicella infection that has happened in the body. Once the clones are produced, they are then going to start to produce thousands of what are known as plasma cells, and also another cell type which is known as a memory B cell. So I want to come back to the memory B cells in a moment, but first I want to talk about what's going on with these plasma cells. Plasma cells, once they're produced, start to make a protein molecule which is known as an antibody. And the antibodies aren't cells, they're not immune system cells, they're really just proteins, but they're kind of the foot soldiers, if you will, in the humoral immune response. When these antibodies start getting produced, they go and they find that antigen, the varicella in this case, and they bind to it to initiate its destruction, or in some cases just to cover its surface so that they can neutralize it and prevent that virus from further infecting cells within the body. So what you see happening here is the primary immune response, and this is going to happen the first time your body is exposed to a particular antigen. So we have a vaccine for varicella now, but back when I was little, kids used to get chickenpox. We even used to have chickenpox parties. And the first time that you got exposed to chickenpox, you'd be in this primary response, where a B cell that's immunocompetent for it is going to bind to it, become activated by a helper T, proliferate into clones. The clones are going to produce plasma cells. The plasma cells are going to produce antibodies. And there's a lag between when that virus is introduced into your body and when a B cell binds it and becomes activated against it, until once we actually have antibodies being produced of about 3 to 6 days. So it takes about 3 to 6 days after the virus is introduced to be able to get activated B cells and then clones and then plasma cells and then enough antibodies to actually do something about the virus and start working to destroy it. In the meantime, you're going to be suffering the effects of that virus infecting your cells and doing its harm to the body, because it's going to take some time to mount a response against that virus the first time that your body has seen it. Now, I talked about previously the memory B cell. So here's a memory B cell here. Antibodies really only last maybe a few weeks in the body. They're just proteins that they're going to start to break down. Memory B cells are B cells that are already activated against varicella. They have already gone through the process of recognizing it, and these memory B cells can stay around in the body for decades, up to the rest of your life. What that means is a month later or 6 years later or 40 years later, if you get introduced to varicella again, these memory B cells are going to be the first thing to encounter it. And these memory B cells are going to bind it. They don't have to go to a helper T cell. They've already been activated against varicella. And so they immediately start to produce plasma cells, which immediately start to produce antibodies. What happens when you've got memory B cells that are responding to an antigen that your body's already seen is what's known as the secondary response. And you'll notice that the secondary response happens much more rapidly than the primary response that we talked about up here. There's not nearly as many steps to go through. And so it's really only a few hours with a secondary response before you start getting lots and lots of antibodies produced. And those antibodies take care of the virus, they neutralize it, they work to destroy it really before you even know that it's in your body. So varicella won't have a chance to make you sick again. The other thing that happens on the secondary response, which could be the second, third, 10th, 100th time that you've been exposed to this virus, is that you produce even more memory B cells that will stick around for years, decades, potentially the rest of your life to give you immunity to this disease. So once we have memory B cells produced, we're considered to be immune to a disease because we have cells in the body that have already been activated against that microorganism and respond very, very rapidly to it if it's introduced into the body again. This is what we're going for with vaccines. So with a vaccine, what we will do is we will inject into your body to initiate a primary response, something that looks like the microorganism that we're trying to vaccinate you against. Sometimes it's really, really weakened microorganism. Sometimes it's just a protein and not even the whole virus or bacterium. It's just a protein from it that your body recognizes, because remember, to recognize means we're just binding to it, but it's either something that looks like it, or it's just a part of it, or it's severely, severely weakened, so that when we inject that thing into your body, the B cells that are immunocompetent to it are going to recognize it. They're going to bind to it. They have no way of knowing that it's dead or not even a real virus or bacterium. So they go to a helper T activates them against it. They proliferate into clones. The clones produce plasma cells. 3 to 6 days later, you've got antibodies circulating in your bloodstream for whatever that microorganism is. But the most important thing is you also have the memory B cells. So you've got your immune system primed. That way, if you ever get exposed to the real virus or the real bacterium that you've been vaccinated against, you wouldn't even know it, because the memory B cells would bind to it and produce plasma cells and antibodies so rapidly that they would just neutralize it, destroy it, get rid of it from the body before it even has a chance to make you sick. So this diagram here is kind of looking at the same thing that we talked about with the last slide, but in just a little bit different way. So I want to explain this a little bit. we've got time in days on this x-axis. We've got levels of antibodies in the blood on this y-axis, and day 0 is the time that you get exposed to some harmful thing. We'll say it's varicella virus, just going with what we talked about previously. This blue line is representing numbers of antibodies in the blood. So you'll notice on day 0 you get exposed to, we'll say it's varicella, and for about 3 to 6 days you really don't have an immune response to it because your body's going through that process of getting a B cell activated, producing clones, producing plasma cells, producing antibodies. Finally, about 6 days later, we start to produce some antibodies. Those levels start to increase, but it's really 7 to 10 days before we've got sufficient levels of antibody to do anything about that microorganism that has been introduced in the body. So you're going to be sick from the time that you get exposed until 7 to 10 days later, maybe potentially longer, depending on the illness and depending on how healthy your body is, just because it takes that long to produce antibodies and get sufficient numbers of antibodies to do anything about it with a primary response. I talked about the fact that antibodies are just protein molecules, and for that reason, they're not super long-lived in the body. And so you can see shortly after that 7 to 10 day period, those antibody numbers would start to decrease. However, remember that your immune system has now been primed against varicella. And what that means is if you get exposed to varicella again, so this is day 28, it's 4 weeks after the first time you got exposed, you'll notice the antibody numbers shoot up very rapidly. So within a few hours, they're high enough to do something about the varicella virus or the antigen that has been introduced into your body, to destroy it, to neutralize it so it doesn't have a chance to make you sick. You'll also notice that the antibody levels are much higher with a secondary response, and they stay high for much longer with a secondary response. So basically, with the secondary response, it's happening faster and it's happening much, much more intensely than what we would see with a primary response.